Alright, so in this problem, we have a bunch of blocks on the incline, and we have two blocks on the incline, another block hanging, and we're going to assume that M1 goes down, and M goes down, M1 and M2 are going to go up the incline, and our goal is to calculate the acceleration, the tension in the strings, and all the stuff. Okay, so again, pause, draw your free body diagrams. Okay, without any of the other things. Okay, no components, nothing. So draw the free body diagrams, then draw separate diagrams that have also the components and whatnot. All right, so I'm assuming you did that. So I'm going to draw our forces. So for the hanging block M, we have mg pointing down, T1 pointing up. Oh, nothing else. Then for block for block M1 on the incline, we have M1G pointing down, we have T1 pointing up, we have FN1 pointing perpendicular to the incline, and the common force that people always forget here, okay, is T2 pulling it down. So do not forget. If you did, just make sure that you cannot ignore T2 pulling it down. Okay, now for block M2, we have M2G pulling it down, we have T2 pulling it up, and we have FN2 perpendicular to the incline. So this would be our free body diagram. Now, once we have these diagrams, let's go ahead, draw separate diagrams, separate pictures with components and our dotted arrows and all that. So let's do that very quickly. For the block M, we have mg down, we have T1 up, and then since it's going down, we have MA pointing down. For block M1, okay, we have, again, I'm just going to draw all these forces, M1G, FN1, and then T1. We know we need to break M1G into components. So our components are going to be M1G cosine theta. This one's going to be M1G sine theta. Now do not forget, we also have T2 pulling it down. Okay. Now for the last block, we have M2 G down, we have T2 up here, we have FN2, and once again we break M2G into components. We get M2G, oopsies, cosine theta, and we have M2G sine theta. All right. Let's also draw the dotted arrows. This will be for M1A, and for M2 it would be M2A. All right, great. Let's focus on the forces that are only in the direction of motion. So basically, in this case, we can ignore Fn1, M1g cosine theta, or Fn2, M2g cosine theta. We know that Fn1 would be equal to M1g cosine theta. Fn2 will be equal to M2g cosine theta. Does not affect the motion. Now, with these pictures, we are ready to write our equations. Okay, for the block for block M, we have mg minus T1 equals MA. For the block M1, okay, M1 we have a bunch of things that we have to worry about. We have T1 pulling it up, we have M1G sine theta pulling it down, and also T2 pulling it down. So we'll write it as minus M1G sine theta. Don't try to use parentheses and all that, just write the signs correctly. Minus T2, and all this is equal to M1A. And for the third block, for block M2, all we have is we have T2 pulling it up, we have we have M2G sine theta pulling it down, and the result is equal to M2A. Again, writing the equations one below the other, right away you see that there's a negative T1 in the first one, positive T1 in the second one, negative T2 in the second one, positive T2 in the third. And if we just add all these three equations, we are left with mg minus m1g sine theta minus m2g sine theta is equal to ma plus m1a plus m2a. Okay, and if we were to factor g from the left hand side and then a from the right hand side, we would end up with a equals m minus m1 sine theta minus m2 sine theta times g, and all this divided by m plus m1 plus m2. Okay, so this is A, and then go ahead and find an equation for T1 and T2. Do the algebra carefully. Make sure that the only things you have in your answers are the variables that are given and nothing else. Okay, so that concludes this video. Hopefully all this made sense and you're able to take care of homework and things like that. All right, goodbye.